All right, we're going to take a look at notes from 12-1. This is a circle chapter, and throughout this chapter you're going to see a lot of little small theorems and properties that all revolve around circles. First, we're going to start with just some terminology here. You can have a triangle, a pentagon, an octagon, any type of figure. When it says is inscribed in a circle, then basically that triangle or that pentagon or that octagon is inside the circle. Okay, inscribed, the figure is inscribed. And if it's a triangle with 3 sides, it will hit the circle in 3 points. Okay, if this was a 4-sided figure and I say the quadrilateral is inscribed, then it would hit the circle in 4 points. But the figure is inside the circle. When you say a triangle is circumscribed about the circle, you'll notice the difference. The triangle is outside the circle. Or it could have been an octagon or a pentagon or whatever. And since this is a 3-sided triangle, it will hit the circle in 3 spots like that. So when you say a triangle is inscribed about a circle, is circumscribed about, a triangle is circumscribed about a circle, you're not just saying a triangle and then there's a little circle there. You must hit, the triangle and the circle must hit in 3 points. Okay, so inscribed, the triangle's inside, circumscribed about, the triangle's outside. All right, now the big word for this particular section is tangent. A tangent to a circle. Now this is different than the tangent button from a previous chapter, opposite over adjacent. This is basically a type of line. A tangent to a circle intersects the circle in exactly 1 point. So this line going up and down here, if it just nicks the circle in 1 spot, then we would call that a tangent line. Okay, so this AB in this picture is tangent. And point B there is the point of tangency. You're not going to see that word very often, but it's where the tangent line hits the circle. Okay, there's going to be theorems based on tangent lines, and mainly this is the main one here, 12-1. If a line is tangent to a circle, that means you just nicked the circle. Then it is perpendicular 90 degrees with the radius. Radius, of course, goes from the center of the circle to the edge. If this line AB is tangent, then this right here is 90 degrees. Okay. 12-2 is kind of that 12-1 in reverse. You've got this line. You don't know that it's a tangent line. You notice you're perpendicular with the radius. Then this line that we didn't know about, then it is a tangent line. If you just have some random line that is passing through, but you're 90 degrees with the circle, then it is a tangent line. And 12-3 here. 2 segments that are tangent to the circle. So this AB just nicks the circle, and this BC just hits the circle. They're both tangent lines. And they meet at a point outside the circle, like point B out here. Then the 2 segments are congruent. So that means AB here, tick, is equal to CB, tick. Okay, if you meet out here and you are tangent, you just hit the circle once, you are congruent segment, congruent segment. All right, let's take a look at how to do some calculations here. Number 1, ED is tangent to, and then here is the symbol for circle. It basically looks like a circle with a dot in it. And then when they say circle O, they're basically saying O is the center. Find the value of X. Notice it's an angle there. There's an angle here. If ED is tangent, that means here to here is the radius. You are 90 degrees with the tangent line. You had to know that you were tangent. You definitely know that this is the radius because that dot means you're going through the center. Now, what you got here, you're going to figure out angle X here. Notice, though, you have a triangle. All triangles add up to 180. So 38 plus the 90 plus X is equal to 180 degrees because all triangles are 180. And then if you just minus everything over to the other side, you will get x is 52 degrees. Okay, have to know that a tangent line and the radius is 90 degrees. Okay, and again, that's the symbol for a circle. Moving on, we're going to come back to number 2 in a second. Let's do number 3. It says, in example 3, if AO is 4, AP is 7, OP is 8, is PA tangent to the circle O at point A? Well, I kind of redrew this picture because if you just look at this picture here, this doesn't even look right, because it looks like, why are you asking is this tangent? Because tangent means you hit the circle once. This thing clearly looks like it hits it twice. So you don't even need to worry about these numbers. It looks like it hits it twice. So I kind of redrew this picture here. OA is 4, A to P is 7, O to P is 8. Now the question here, is this line AP or PA tangent? Does it just hit it once, or does it maybe hit it once and then maybe hits it again, kind of like it does in this picture? Well, this picture is a little bit more realistic because you don't even need to calculate this one again. So what we're going to do here is figure out this. In order for this line to be tangent, it has to be 90 degrees here. That has to be 90 degrees. I'm putting a question mark, because a tangent line in the radius would make 90 degrees. In order to be 90 degrees, Pythagorean theorem must work. So we're going to test a squared, b squared, and see if it's equal to c squared there. So we're going to say a squared plus b squared, and I'm going to see if it's equal to c squared. And if it is, then that's a right angle. And if this is a right angle, then this PA is tangent. So you just do the basic math here. And I don't believe this is going to be, that's a 5. 65 is not equal to 64. So it's really close. So, but it's still not tangent. So it's not tangent because it does not form 90-degree angle with the radius. Okay? Pythagorean theorem doesn't work. And if Pythagorean theorem doesn't work, this is not 90 degrees. So it might look like it hits it only once, but technically it probably hits it one time and then hits it again. Okay, but it would be harder to see. All right, let's do number 4 here. Circle O is inscribed in triangle PQR. So the circle is inside the triangle. Okay. Triangle PQR has a perimeter of 88. Figure out where QY is. Where's QY? Here's QY. So we're going to figure out that yellow line there. All right. We know if I add up every part of the triangle, it adds up to 88. We got to figure out this part here. Well, how are we going to do this? Well, let's look back at a previous theorem here. When you are outside the triangle, like point B, and these are tangent lines, they just nick the circle, then these outside points are equal. Okay, and there have to be 3 outside points, point P, Q, and R. So this QY is the same as QX, because this line and this line are tangent. This line here, PX, is the same as PZ. And then also this R to Y is the same as R to Z. We're not saying that this is halfway. The yellow is equal to blue or the yellow is equal to pink. But we are saying the pink is equal to pink, the blue is equal to blue, yellow is equal to yellow. So if this is 15 out here in pink, this is also 15. If this is 17 in blue, this is also 17 in blue. If this is the unknown X, then this is also unknown X. And we're going to figure out what the yellow is. But we do know all of it adds up to 88. So what we're going to do is go 17 blue plus 17 blue plus 15 pink plus 15 pink plus X in yellow plus X in yellow is equal to the perimeter of 88. And then from here, we just use the calculator. And I'm going to add up all these numbers, and that's 64 plus 2x is equal to 88. And then we're going to minus 64 from 88. And so it looks like x, the yellow, is 12. Okay? But when you are on the outside, these two outside segments are equal because you are tangent. Okay, we're going to now go to number 2 and finish this thing up here. This one's pretty tough. A belt fits tightly around 2 circular pulleys as shown. Find the distance between the center of the pulleys. So here's the 2 circle pulleys. So we're going to connect this line here. And we're going to figure out what this line here is. Well, what we got to do, and I'll just call that X for now. We have a trapezoid here. We have 90 degrees, 90 degrees. What you need to do is draw a line that separates this into a rectangle and a right triangle. And that's going to be this blue line right here. You go from the small center and connect it to the radius of the bigger one. Now you have a rectangle here and a rectangle here. If it's 8 on the small radius, it's 8 over here. If the entire radius was 14, 14 minus 8, this would be 6. And you have this really thin right triangle here, where it is 6. If this is 35 in a rectangle, then this other side of it is 35 inches. And so this again is 35. And then we would go a squared plus b squared is equal to c squared on this little red triangle here, this really thin red triangle. So we're going to now go a squared plus b squared is equal to c squared. The key here, though, to start is, again, this drawing from the center to the center of the small one to the radius of the bigger guy, splitting into a rectangle and a triangle. Oh, by the way, this is 36. 35 times 35 is 1,225 x squared, and I'll add 36 to that. 1,261 x squared, and then the square root of 1,261. 35.5 inches is the center pulleys. So again, you go from the small center and then connect it with the radius of the bigger one to create a rectangle and a triangle.